Alright, stream's up. Red pen. Oh, there's another straw. There it is. Oof. Alright. My AP classroom doesn't want to load. Anybody else having any issues getting into AP classroom? Oh, there we go. Never mind. Okay. Number 1. Okay. Take that as a no. Number 2. Take that as no.
Yeah.
Said you need number 2, Bacon?
It's just my thing was still loading, so
Okay, you're fine. But that's your question. How did you miss your question?
I didn't know how to do it.
Alright, College Board and let them know you couldn't do your own question. Uh, that's the weirdest bank account I've ever seen. You can't add any money to it. Okay. I'm thinking C would be the answer without looking at the answer.
That's what I put, but it's not.
So balancing account. Uh, that it's kind of weird. Oh, that's because if you look at it, it would be she continuously withdraws the rate of NT. So when you do your derivative, because that's what they're looking for, dp dt, you would get NT. So it wouldn't be 0.02 NT. I see why now. So basically, think about it this way: think of taking like the antiderivative, basically. So when you go to take your antiderivative, you wouldn't have 0.02 NT. It would just be NT. So the n has to be by itself, not with the 0.02. That makes sense. All right, does that make sense? Very good.
Yeah.
Okay. All right, number 3. God, they're having you write a whole bunch of differential
I
equations.
missed that one.
You almost never write a differential equation. You just solve differential equations.
There's
Okay.
like a ton of them.
Yeah, this is at time t, the rate of the number of words proportional to the number left to be memorized. Okay. So it's proportional to the number of words left to be memorized. That's an important thing as I'm reading. So which expression in here gives the number of words left to memorize? So if there's a total of 100, so it's going to obviously be something with 100. And L is the number of words memorized. So 100 minus L, so I would say C. And yeah, that's right. You see, I figured that out as far as the 100 minus L thing.
Yeah, I did B.
B, I can understand why you put B, but that's not proportional. So when it says that the, where's it at? The rate of change in the number of words, aka DLDT, left to be memorized. The number of words memorized, sorry. So yeah, DLDT equals, it's going to be K times something. That's what it means to be proportional, like a direct proportional relationship. It could be inversely proportional, but obviously it's directly proportional. So that's why it would not be B. Can we have some actual math? Yay, actual math.
Yeah, I guessed on this one.
I didn't get it. I don't know how to do it.
The easiest way to do these kinds of problems, because you guys can't do it the other way, is to plug in y and y prime.
What?
Pick which one you think it is and plug in y and y prime to see which one you think is the answer. Especially because if you actually did the anti-differentiation, then you would not be getting the answers they have here. So they're not asking for necessarily the antiderivative of this equation. They are asking for which one is a solution to this differential equation. That's like saying, if I give you an equation, what is the solution? You could just take all of those and plug them in and see which one works. That's basically what they're wanting you to do.
What do you mean when plug them in?
So if I gave you like x squared plus 5x plus 7 equals 12, and I gave you 4 solutions, x equals 2, x equals 3, x equals 5, and x equals negative 1. If you didn't know how to solve that equation, all you have to do is take the answers, plug them in for x, and see which one works. So here, what you'll do, the easiest way to do it, is you will plug in y for y, take the derivative and plug that in for y prime, and see which one works.
Interesting. And it should equal what they gave us, like the x, y prime minus.
No, it'll equal 2 when you plug it in.
Oh, gotcha.
You're just plugging into that equation to see if it's an answer or not, basically. That's the easiest way to do this by far. That's really the only way you're going to be able to do this problem. Like I said, even if you do because there is a way technically to take the antiderivative of this and solve this differential equation, but you would not get the answer that they are giving you. You would get something much different. So the only way to really do it is to take derivatives and plug them in. Yeah, anytime you have an equation and they're asking what a solution is, one option, especially on multiple choice, is always to just plug in the answer choices. Does that make sense to everybody? Or do I need to show you or do anything? Okay. Number 5.
I need number 5.
Okay.
I think. Oh, never mind.
So this is going to be the same thing as we just talked about. So basically they're asking which ones work. Right off the bat, I can tell you that 3 does not work. Because if you take the derivative, you get cosine, and you take the next derivative, you get sine. So if you plug that into your equation, you would have a sine function minus a cosine function plus a sine function equals 0. Since they're not squared or anything like that, that's not going to work. Like the sines may end up canceling out, but you'll have some sort of cosine left, and that's just not going to work. And by looking at the answer choice, 1 and 2 work, so I can show out. So double prime minus 5. I think that's what it was. Make sure. 5 plus 6y. Yeah. Then you have e to the 2t and 3 to the 3t. So if you do the first one, you have y is equal to e to the 2t, so y prime is 2e to the 2t, and double prime is 4e to the 2t. So you get minus 5 times 2 plus 6. Oh, yeah.
It's 5y, just single prime, not double prime.
Oh, thank you. So there's the first one. You'll be able to see it in a second after I move. But second one's done the same way. You just take the derivatives, plug them in, and if you don't get 0 on the left-hand side, it's false. If you get 0 on the left-hand side, it's true. Like I said, you don't even really need to work out the third one, just because I automatically looking at the derivatives, you know it's going to be sine, cosine, and then sine again. Doesn't matter if it's positive, negative. You'll never be able to add or subtract those to get to 0, unless it's squareds and things like that with some identities. Does that make sense? Okay. 6 is the same way. Do I need to show that one? Are we okay?
So for these, the really only thing you can do is like plug them in.
If you're trying to find a solution to the differential equations, then yes. Unless they ask you to, unless it's you can sometimes do them by hand and do the antiderivative. But if you're checking to see which one is a solution to the differential equation, then the easiest way to do it is just to take derivatives and plug them in. Yes.
Okay.
Now, obviously
Yeah,
on the...
I didn't
Go ahead,
I
Sue.
didn't know that you could plug them back in. So I watched this video and it used U and V and DV and stuff.
You mean
And I
integration
tried
by
to
parts?
yeah, but backwards kind of.
You can, depending on the problem. Most of these problems that you're seeing you're not going to be able to solve them by basic methods of anti-differentiation. So these would be things that would be much harder. This is where you'll get into differential equations. If you take a class after Calc 3, you'll start learning how to do some of these. And then some of them you don't even do, like some of the stuff you wouldn't even do until like a graduate level integration class. So they're not meant for you to take the derivative or antiderivative at all.
So then this won't show up on free response?
Something like this, probably not. Solving a differential equation could definitely pop up. But necessarily like picking a solution like multiple choice, no, not necessarily. I don't think it could.
Okay.
7, a slope field.
I got this one wrong, but I did it how you do slope fields. So, yeah.
Okay, so let's look for a pattern then. So as you get closer to 0, either way, it looks like it's 0. So all of those satisfy that. We can throw out D, looking at the answer choices, because if it's just y squared, then as you move up the y-axis, it would be getting steeper, which does not happen. So D's out the window. And then at that point, just start picking some. So I look and see that, like, what is it? C is also out the window, because if I go to like 3, like whatever that is, 0.25 or whatever, then that should be much more positive than that is. That's getting close to 0. It's flat. So just by moving right, we're not getting very much steeper. So C's out the window. X squared plus y squared. And then again, same thing with A. As you move up the y-axis, if that would be getting steeper, because y squared is going up, but those lines really aren't getting any steeper. So I would be left with B as my answer choice.
So for slope fields, can't you like let's say that like at 1, 2, can't you like evaluate it and like see like if the slope kind of looks like that?
Yeah, you can. You can pick specific points. I look for general, like just kind of patterns. So like I look, where is it flat? Where is it go vertical? Does that make sense? So for instance, you could pick like 3, 2. That's super vertical. It's positive vertical. It's not negative vertical. A couple things like that. So that's why you just need to look at those points and see, does that make sense? Should it be positive? Should it be negative? Should it be flat? Should it be really high? Most of them it works for being really positive because they're squaring a lot of things. It probably shouldn't be quite that positive for like D, so that's why D is out. Y squared, that's a little more than a slope of 4. So that's why I'd throw D out. Then you can pick, like you said like what, 2, 3, or 2? What'd you say? 1, 2. So if you pick like 1, 2, then that would be negative if it was C. So you could throw C out from that point, because 1 squared minus 2 squared should be negative. And none of these slopes are negative anywhere. So C is automatically out. And then just kind of keep going through them and seeing which one works until you can find a counterpoint for all of them but one. Okay, number 8.
I mean, I missed it, but it's slope fields. So
So what did you put?
I put B. I'm not good at slope fields, and I just guessed.
B is not a bad choice. What I look at is I look at the line of 1. It's all a bunch of horizontal lines. So if I plug in 1 for y, it better be 0. So that makes sense, okay. The other thing is, if I look at where 0 is, so if y is 0, it should also be 1, or it should also be 0 by looking at the slope field. So that makes sense that it's 0. It would also be possibly an undefined point, which I don't think it is. Yeah, I think it actually does end up being an undefined point, but whatever. So things like that. Let's see. The reason yours doesn't work, Ivy, if you look at the negative side down here. So if I pick negative numbers for y, then it should be, in your case, it would be a negative slope, but those are not negative slopes for negative y values.
Okay.
So that's why it can't be b. And the only other one it makes sense for, based on the horizontal lines, is d. Because a fails where y is equal to 1. That's not a slope of 0. And so does c. So it can't be a or c as soon as we look at that horizontal line. It's got to be b or d at that point. And then you just got to pick other points until you realize one of them's right, one of them's wrong. So try points like above it and like at the top, points at the bottom. And since we're only relying on the y value, it doesn't matter if you move left or right. It only matters if you move up or down. So just make sure whatever you have fits that pattern. And that's why in between the 0 and the 1, you have that kind of weird pattern there, because it's the y squared minus y, and it's weird for those values.
Okay.
More slope fields. Let's see, so for this one, I might almost like just pick some points. So this one should actually be 0 on the diagonals. So I would look for one that has zeros on a diagonal, and it looks like the only one that happens on is B. So it should have zeros on both diagonals through the line y equals x and y equals negative x, because it's y squared minus x squared. So like 1, 1 should be 0, 2, 2 should be 0, negative 1, 1 should be 0, all those kinds of things. They don't do a very good job of zeros, but kind of close to 0. Does that make sense how I figured that out? Taking the silence as a yes. Number 10.
I didn't know what Euler's method was.
Euler.
Didn't know.
Euler's method is the one that we did the chart for when we did it.
Yeah, I had no recollection.
I'm pretty sure we did it.
I don't. What chart?
You make a chart with like x, y, dy, dx, and then dy, dx times delta x, etc., etc. There's a little chart we did with it. I'm pretty sure we did it.
I don't think so.
I thought we did.
I do not recall, but I don't know.
I may have also pushed it off towards the end. I don't know. I could be. I thought we did, but I don't know. I could be misremembering. It's not a big deal. But yeah, Euler's method is like really easy. To be honest, all you do is just do your chart. So Euler's method, to kind of go over it, since I'll just say I didn't, kind of go over it, is a method of linear approximation, basically. So, I don't think I went over Newton's method last year, did I, with everything?
I don't think.
Okay, so Newton's method, which we would have went over last year if we had time, is a method for finding zeros using the IVT. Euler's method is a process of linear approximation. So basically, if we have, let's just do a parabola. So if we do a parabola, and let's say I know that point there. If I do a linear approximation, then I would get something that looks like that. And then I start here, and I do another one. Then I would get something that looks like that. And then that. So I kind of drew it off the graph on purpose to kind of notice the differences between them. So if you use a linear approximation, I'm going to hope that we all remember that they are fairly inaccurate, especially once you start moving away from that point. So what Euler's method does is it does a linear approximation, but only moves a very small distance, and then does another linear approximation and moves a very small distance, and then starts another linear approximation. So instead of having just a line to represent the curve, I have a bunch of lines. I'm going to assume at some point everybody's seen those pictures that are full of straight lines that makes it look like it's curved.
Yeah.
It's basically that as the idea. Is if I put a whole bunch of straight lines together, I can get technically a curved line. So it looks curved, but it's really not, because it's just a whole bunch of little small turns. So that's what the whole idea is. So I can get a relatively close representation of that graph from using multiple linear functions instead of just one. And obviously, the more you do, the more accurate you get. So the idea here is, if we want a curve sketch, we change our length of our linear part to be smaller and smaller and smaller, and we get a better, more accurate representation of the curve. That's what Euler's method is. It's a way of looking at a curve and figuring stuff out. So let's see. They give us an initial point, which is important, and a step size of 0.1. Okay, so when we do our chart for it, a couple pieces of information we need. So what do we need in order to write the equation of the line is really the question. Well, we need our point, so we need an x and a y. We need the slope, so you need dy dx. Let's see. And then we need to figure out, it's dy dx times delta x, if I remember it next in the chart. It's been a while since I've looked at it. And then I believe it is y plus dy dx times delta x, if I remember correctly off the top of my head. Yeah, right. Okay, that is correct. That's probably the best order too. Okay, so in our case, they told us to start at 1.5. So x is 1, y is 0.5. They've given us, what, dy dx is 3x plus 2y.
I can't hear you.
Mother. How long ago did I cut out?
Like 10 seconds, 15 seconds.
Okay, good. Okay, so I filled in the first line of the chart. I don't know what you heard. So they gave us the x and the y. So I filled those in. and then use the equation for dy dx that they gave us to plug in the x and the y to find my dy dx, my slope at that point. And then I move along the slope 0.1, so that's where the dy dx times delta x comes from, which is the 0.4, and then add that to the y value. Does everybody see where I got all those numbers from? Anybody have any questions of what those numbers represent? Making sure that's a more important process in doing this process, because you don't have to necessarily create the chart. The chart is by far the easiest way to do it, but make sure you understand what the chart represents and what each of those pieces are. So obviously the x and the y is the x and the y where you start. The dy dx is the slope. And then the dy dx times delta x, that is the change in y, because that's the slope times the x value, which is going to get you your delta y value. And then the last line is the y plus delta y. So is everybody okay with the first line? Okay, well, at that point you just do it all over again, except for you have new starting values. So if I've now moved 0.1, I'm at 1.1 for the x, and my new y value would be 0.9. So then we plug that in to our new delta y, because we're going to have a different slope at that point. So 3.3 and 1.8, 5.1, and then 0.51. Add that to that, and I get 1.41. So at 1.2, I'm at 1.41. And that's my answer. Do you have any questions on what I did? Oh. Are there any questions on what I did? Why are you... Okay, there we go. All right, any questions on what I did? I will take the silence as a no. Um, 11 will be the same way, so I'll leave that one for you guys to go back and practice, since I don't know how many of these questions there really are. But it's the same thing, just make your chart, do your linearizations, and go from there. They're pretty easy problems if you can remember the chart, but the big thing about it, don't just memorize like the chart. Look at it and go, hey, I'm writing a bunch of linear equations. What do I need to write the equation of a line? Well, you need your x and your y. You need your slope. And then the last two parts, those are figuring out like your rise and your run. Or actually just your rise, because you know what your run is. You're figuring out your rise based on the given run, which is your step value. So it's really not a complicated process. It looks a little daunting, I understand, but once you figure out really what it is, it's not too bad.
Will you do 12?
Sure, I'll do 12. So let G be a solution, differential equation, okay.
Missed this because step is technically negative 0.5, but
What is the approximation if use it starting with 3 steps of equal size? So yeah, so each step is negative 0.5. You went up positive 0.5? Oh yeah, you gotta be careful with that. So yes, so notice here they didn't tell you what the steps were. They just told you that 3 steps of equal size. So that means that you need to figure out what the step size is. Well, they gave you whatever your starting value is, which is 1.5 in this case, and they want you to get to 0. So how do you get from 1.5 to 0 in 3 equal steps? And it's negative 0.5 each time. So your delta x is negative 0.05 or 0.5. What's the differential they gave us? 1 minus y. And the original point is 1.5 negative 1. So our slope according to this should be 2 at that point. 2 times negative 0.5 is negative 1. So negative 1 plus negative 1 is negative 2. So then I go 1, because I go backwards 0.5 in this case, because my delta x is negative 0.5. And my new y value is negative 2. Now my slope is 3. Negative 1.5, so negative 3.5, and then 0, or not 0, negative 0.5, negative 3, then I get 4, negative 2, negative 5, so 0, negative 5. There's my answer. Oh wait, I did something wrong. What did I do wrong? Oh, I put negative 3 instead of 3.5. I wasn't paying. I don't know how I managed to blunder that one. So that's 3.5 there. So dy dx is 4.5. 4.5 times 0.5, 2.25. I think I did that math right in my head real fast. And then that's negative, yeah, there we go, negative 5.75.
So the of the table is the derivative times the change of x?
Right, so think about it this way. This is your... So you have like your little slope triangle. It'll pop up in a second. So the actual slope is dy dx or delta y delta x. Doesn't so if we're doing it as a line, technically this line is the same thing as delta y over delta x. So because we're using it as a line, not as an actual like derivative, so we find the value of dy dx. At that point, for a linearization, your dy dx becomes the slope of your line. And because it's a linear relationship, we know dy dx is delta y over delta x. Well, if I know the delta x, how do I find my delta y? Well, I could do delta y over delta x times delta x. That is your delta y. So this line here really is your delta y. And that means the second, or the last, or column, not line. That means your last column is your y plus your delta y. So the dy dx times your delta x is a fancy way of saying dy, what is the change in y? Does that make sense? Anna?
I said yes.
Okay, sorry we didn't hear you. So that's really where it comes from and what it is. Like I said, this is just a fancy tabular way of doing a bunch of line equations, because technically you could write the linear approximations, then plug in your new points and do it that way. This is just a more succinct way of doing it that'll save you a decent amount of time if you remember the chart. But basically you're just doing a whole bunch of line equations over and over. Alright, let's see. How long is he? Not what I want to go in. Okay, and we will do part B, I guess, tomorrow, and then start the free response and finish free response on Thursday. Sound good to everybody?
How do we use the calculator to solve the differential equation?
Solve the differential equation.
Like, I'm just looking at number 1, and it's a calculator question, and then it gives you a differential equation and asks you what f of 2 is.
Which part are you on, sweetie?
Part B.
Okay.
I haven't done it yet, but I was just looking.
Because you're not going to be able to plug in 2 for the x value there, because it's going to be there's going to be an exponential, like an e in there. So you'll separate your variables. So multiply both sides by e to the y, and then multiply both sides by dx, and then do your antiderivatives. So on the left-hand side, you're going to end up with e to the y. Yeah, so the antiderivative of e to the y dy is just e to the y. So you get e to the y is equal to 1/3 x cubed plus x plus c. Solve for your c by plugging in 1 and 0. And then plug in 2 to that new equation and solve for y. So you're going to have ln's and stuff in there. Because to get the y out of the variable, or out of the exponent, you have to use, you'll ln both sides.
Okay, that makes sense.
Any other questions about anything before we adjourn for the day? Alright, make sure you finish up your part B and not 15 minutes into class next time, Mr. Max. Yeah, I pay attention. Other than that, there are some, if you haven't noticed or haven't paid attention to AP, there are some free response questions they put out that are supposed to be more aligned to this year's exam. I was planning on saving those for a little more towards the end. So let's see, how many more free sections do we have? It's all free response. What are you talking about? Good to know Tanner is ready for this test.
Man, throw something in front of me, I might be able to.
You probably will. So we have what? So we're doing 6 now. Or we're doing 6 or 7 now? I don't remember.
We're on 7 now.
So, okay. Alright. And, wait, where's the... Let's see, I forgot what units they took out on us. Calc BC. Alright, so we don't have to do Unit 9 at all. And then we have to do part of Unit 10, so we'll kind of pick and choose, and we'll kind of just go over some of the stuff there. So we have 8 next week. Okay, so that would actually not be too bad. So what we'll do is we'll do 8 next week. The following week we'll kind of go over 10, which will lead us up to the 8th. And then your test is the following week. So next week we'll do 8, and then the following week we'll kind of do a little bit of 10, and then go over the kind of the review questions that they have made. There's also a really good like practice like mock test that somebody has made in the AP community that we will do like that week, so you guys can kind of ask questions and stuff like that. But then we're done. We're almost there, guys. You'll never have to listen to me about math ever again. You said like half of a statement there, Tanner.
Oh, wait, is it cutting out?
Yeah, I only heard like 3 words from you.
Oh, I think I said too quiet. I said we'll have to listen to mean old professor.
I doubt they'll be as mean as me. They just won't be as helpful as me.
Same thing.
Any other questions for anything?